Now we know that electrons exist in only certain energy levels, and those locations where the electrons are found are called orbitals. And we can match what we know about orbitals with complicated mathematical functions that have certain variables that we have to plug into those functions. And so these variables are what we're going to focus on. We're not going to focus on the mathematical functions. We're just going to talk about the variables. In other words, the input, the numbers that you input into the formula to give you the answer. So it turns out there are 4 of these variables, and these variables are called quantum numbers. And the first one is called the principal quantum number, and we're going to abbreviate that with a lowercase n. So what's important is that you remember that it's called n. You don't really have to remember that it's called the principal quantum number. And there are certain rules associated with these quantum numbers. So the rule for n is that it can be any whole number that is greater than 0. So another way to say that is n could either be 1 or 2 or 3, so on, all the way up to infinity. And the larger the value of n, the higher the energy of the orbital. The second quantum number is called the angular momentum quantum number, but we're going to abbreviate that with a lowercase l. And it turns out that L tells us something about the shape of the orbital. So quantum number n told us about the energy. Quantum number L is telling us about the shape. And the rule is now that I'm plugged in, the rule for L is L can be any whole number that is starting at 0, going up to a maximum of 1 less than whatever the quantum number L happens to be. So we start with L first because L limits our choices. We start with n first because n limits our choices for the quantum number L. The third quantum number is called the magnetic quantum number, and that's abbreviated with an m and a subscript l. So this is usually called m sub l. And m sub l tells us about the orientation in three-dimensional space of that orbital. So n tells us about the energy, l tells us about the shape, and m sub l tells us about the orientation. And the rule is m sub l can be any whole number starting at negative L and increasing up through 0 and then to positive L. The fourth and final quantum number is called the spin quantum number, and that's abbreviated with m subscript s. So this is called m sub s. And the spin rule is the easiest out of all of them. The spin can either be positive 1/2 or negative 1/2, and those are the only choices for the spin. Now we call it spin, and we can picture this as an object spinning either clockwise or counterclockwise, or we can also think of it as a magnet which is going to point to the north. So north could, if we have one end of the magnet and we don't know which end is pointing north, could be pointing up is north or pointing down is north. We're going to take all 4 of those quantum numbers and put them together to make one set. And that set is similar to an address for each electron in an atom. And when we do this, when we make our set, there is a key rule, which is no 2 electrons in any atom can have the same set of 4 quantum numbers. So if we have an atom, let's say it has 82 electrons, all 82 electrons have to have a unique set of N, L, M sub L, and M sub S. They could have 3 of the 4 be the same, but the 4th one has to be different.